Hello guys, so this is part 2 of the basic virtual reality locomotion with Unity. So on the previous part of the video, so we have the camera, our player, the dome, the point light, and the Google VR viewer with the script. So what's left to do is actually the navigation pods that we wanted to create. So to do that we need a canvas, some buttons, and of course we need something to interact with those UI buttons. So what we need is this tiny little pointer in front of us. So in VR it's called the reticle. So to create that we need to go to our main camera in child, empty game object, and call it reticle. So inside this game object we will put the script from Google VR SDK called Google VR pointer or reticle pointer. So if this error appears, the solution is actually create a mesh render, because we're going to render a tiny little material in front of us, so we need a mesh render for that. So now we can add the Google VR reticle pointer. So the default values of the segments and growth speed is 20 and 8. You can notice that increasing. If you increase those numbers, you can test that anyway if you like. So now let's test it. So as you can see, there's a big circle blocking both eyes. So one thing that we can do about that is to add the material from Google VR called the Google VR reticle material. So this material actually reverses the previous object, so you can actually play with the colors. So mine's red, so if you want to change that, you can just click this box right here with the color and change it to whatever color you want. So change it to white. That's it. So now we should create the canvas. So the canvas will be inside the UI tab and set the screen space to world space. So canvas render mode should be world space. Why? Because one of the best practices in VR, so UIs should be a part of the world. So we need this UIs to be a part of the world, like in Iron Man, where he plays with his interfaces, like moving objects, like physical objects, using hologram technology. So that's the same thing. So our canvas position of X, Y, and Z should be 0, so we can center it out easily again, because it's so big. So rotate is X to 90, so it's like a flat bed now. So you can now imagine what's going to happen. So just about that position, and go to canvas, right click, UI, add the button. So let's position the button in front of us so we can see what's going to happen if we interact with those. So the text, you can remove that. So one the components that you can play with in the button is its color and highlighting color, press color. So if you want its normal color to be changed, then you just have to play with the palettes right here. I want it to be gray, so when I highlight it, I want it to turn to green. If I press it, I want it to turn to red. And if it's disabled, let's not play with the disable function. So let's test it. So as you can see, nothing happens, because we're missing something very important when you use canvas. So as you can see, canvas automatically added an event system, and this event system will be used in canvas for input modules. So we can actually delete this standalone input module because we are not using controllers in here. And now we need to add Google VR pointer manager and Google VR input module. So this two scripts right here will be the the input controls for the canvas. So let's test it. Now we can interact with the buttons. The only things that missing is actually the script that will make us move from this position, our default position, to the position of the button right here. Note that the position should always be the same height with our current camera. So to do the script, let's create a folder. Again, let's be organized. Let's create a script folder, enter, create a C#, call it Locomotion. Locomotion. I missed a minute. Oh, okay. Now enter. So we have here a Locomotion script. So this is a void start. It's used for initializations. Void update, which is called once per frame. So if you're coding using C#, you probably know already what this means. But if you're new, so start functions inside this lines will be called only in the start of the scene, and the update will be called once per frame. So if like you're shooting a bullet, then the function should be right here because you are shooting a bullet every frame and every second that passes. So now what I'm going to create are some variables. So starting for the starting part of coding, you will think of what you want to do. So I want my default position to be transferred to another position, so it's from X to Y. So what I need to do is transform, or rather transfer myself to a position that I want. So transform is the position, rotation, and scale of an object. So this will involve the current position of our player. So that is why we need the transform function right here. So public transform our default position. Oops, and close that. We'll call semicolon rather. Sorry, and transform position 1. So I have now two variables for two different positions. So what I need now is what am I transferring? So I'm transferring a game object. So public game object, because our player is a game object that's inside the scene. So public game object, our player. Now we will use the buttons. In the button, there's an on-click function which you can add. So add to list. Now the runtime object inside the scene is required. So we will create another empty game object. But first, let's finish the script. So we need the methods inside the script to be accessible. That is why we're going to use public void. I'm sorry about the noise, I'm using an MKV. So let's just say default position. Okay, so now if I access this method inside the button, what will happen? So what's going to happen is my player's transform the position. So the player's position will be equal to the default positions dot position. So I transferred my player's transform position to default position. That's too many positions in one line. So let's just copy this, because this method is for the other position. But of course, this will be equal to position 1. Right there. So actually that's it. This one line right here is the core of our locomotion. So in the bottom, of course, if I move here, I want to go back where where my previous position is. So let's just copy that, and for both buttons we need to create the motion script. So we need to create the runtime object. Now this is where we're going to place our script. So in the variables, it's a public variable, so we need to feed it game object, so the default position right here in the transform, and in the player, of course, the player, which is a game object. So let's just feed it the player. Next is the position where I want to transfer. So let's create a sphere, and here's the trick that I use in creating this. So I got a camera, so note that the height of the position you're going to transfer should match the position of the camera in the previous place. So here, the height or y of my camera or my player, sorry, is 1.612. So it should be the same with these. Now just copy and paste the values right there, scale it, go to the bottom and place this to the center. Why am I placing this to the center? Actually just to see if my game object is the same as the position of the camera. So right there. Now just copy this. So let's zero this out, X and Z. So this will be, of course, my default position, and this will be position 1. Now we can feed the locomotion script with these data. So for the position 1 we will have this, and for the default position we will have this. We don't need to see those spheres anymore, so let's delete the colliders and the mesh renderers, mesh filter. Now let's test it if it actually works. Nope, it doesn't work because we didn't assign it to the button. So the locomotion script game object should go here, and for the functions, since it's a public void, we can actually access that right here. So here's our default. Let's name this first position 1. So the default, of course, function that we're going to place is our default position, and for the position 1, the pos 1 or the position 1. Now let's test it again, and we have ourselves a very simple locomotion in VR, mobile VR rather. So this is for Google Cardboard. Now what's the only things missing is, of course, the fading effect and the audio effect. Those are just a few lines of codes, so it's very short, and I will do that in the next video. So I'll see you there again. Goodbye.